Alright guys, today we're going to be talking about functions, writing rules for functions, and our goal today is going to be able to identify independent and dependent variables, write an equation in a function notation, and evaluate a function for given inputs. So take a minute, copy down your 2 targets for today, and also work on your warm-up. You should feel pretty comfortable with these, so you've probably done this before, most of you. Determine a relationship between the x and y values and write an equation to represent that. So what am I doing to x to get y? What's the relationship between this number and this number, this number and this number? Take a minute to complete those 2 warm-ups and pause the video, and then we'll get started. Alright, hopefully for this first warm-up you can say, what am I doing each time? Notice I'm subtracting 3 each time between the x value, from the x value to get to my y value. So y equals x minus 3. We want to get used to recognizing patterns. When you write rules for functions, you're always going to be looking for patterns. Even if the points are given to you as ordered pairs in a set, you're doing the same thing. What am I doing to 1 to get to 3? The same rule to do 2 to get to 6, 3 to get to 9, and 4 to get to 12. Hopefully you're saying, well, y is equal to 3 times my x value. Okay? Well, a function is, we learned yesterday that a function is that each x value is paired to exactly one y value. Each input is paired to exactly one output. Function notation then is just a certain way that they write it. So it's a concise way to relate the input x of a function, and we typically use the letters f, g, or h to its corresponding output y. The input is also called the independent variable. It's independent. It can be whatever we want it to be. And the output is called the dependent variable then, because y depends on what you put in for x. Now you also need to make sure you write this down. I want you to get used to speaking like this, speaking mathematically. F of x is how you read this, f of x, or y is a function of x. Maybe make a special note. This is not f times x. It's not the same thing. It is read as the function of x. That means whatever is in your parentheses here, this is what's in your function. Okay, that variable is what is in your function. So you may want to write that down as if this is the first time you're seeing function notation. Okay, so you can do the same thing now with your warm-up. If you go back, we could write this as a function. We could, instead of writing y, replace the letter y with f of whatever variable you put in. X is what was in the equation. There you go. It's the same thing. That's all it is. Y is equal to f of x. Same thing over here. I could say a function of x is 3x. That means when I put x into my equation, every time I'm multiplying it by 3 to get my output. So use the following table to write a function in function notation. Relate the input x to the output. You need to copy down the table on your notes, so make sure you get that. Again, you're looking for a pattern here. So what am I doing each time to x to get to y? Hopefully you see it pretty quickly here. We would write our equation originally as y equals, well, each time I'm dividing by 5. So y equals x divided by 5, or y equals 1/5 x. But we want to write this in function notation. So instead of writing y, just replace it with either f or g or h, and then of, remember whatever you put in this parenthesis is whatever you put into the equation. So f of x is equal to 1/5 x. That's the only difference, guys. Read it as f of x is 1/5 x. All right, then for number 2, you need to make sure you get your directions. Identify the independent and dependent variables in the situation. So we're not going to solve anything for this first one. All we're going to do is identify what is independent, what can be whatever I want it to be, and what is dependent in this situation. What is depending on that first value? A veterinarian must weigh an animal before determining the amount of medicine. Okay, so take a minute to think about this. They must weigh the animal before determining how much medicine they're giving. So what is independent and what is dependent? Well, they're weighing the animal first. That is independent. The animal could come in weighing whatever it wants. So it's going to be animal's weight for independent. But what does the doctor do based off of that animal's weight? The doctor then determines the amount of medicine, so that's going to be dependent. It depends on how big the animal is. The bigger the animal, maybe the more medicine it needs. The smaller the animal, it needs a smaller dosage. I foster kittens, and I see this when I foster my kittens. They need a different amount of medicine depending on how big they are. So sometimes I have to have 3 different doses for 3 different kittens. All right, so now let's put this together. What you did in 1 and 2, we're going to put together for number 3. So you're going to write a function for the following scenario, and you're going to identify the independent and dependent variable. Guys, remember when you write a function, you still need to define what your variable is. But guys, when you define your variable, it's going to be your independent one. So you can just put that right over here. All right, let's read this situation. A math tutor charges $35 per hour. So what would your function be, or your rule, to represent this situation? So you might be thinking y equals 35 times x, except we're going to use function notation. So let's use f of x is equal to 35x. $35 per x. What does that x represent? It represents hours. If you know what's in here, whatever goes into your equation is always your independent variable. So number of hours is your independent variable, and here you go. Now it's defined. So instead of having to write the separate line of x is number of hours, when you define your independent variable, you can put the x right next to it, and I know what it stands for now. What's dependent then? Well, there's 2 ways you can look at this. What does this equation represent? What does f of x stand for? If I plug in 1, it would be 35. If I plug in 2, it would be 70. If I plug in 3, it would be 105. So what is f of x representing here? Those numbers are either the tutor's profit, so if you said that, that works, or, or you could be looking at it from the customer side. It's the tutor's profit, or it's their payment. So if you are the one getting tutored, then it's the payment that is due. Either way, both of those would work depending on what you want to represent here. So pause the video, write down the rest of B, and try that one on your own, and then press play. Okay, so for B, again, we want to do the independent and dependent variable. Guys, you can write the rule first, or you can set up the independent and dependent variables first. It doesn't matter here. A fitness center charges $100 initiation fee plus $40 per month. So the number of months is going to be my independent variable. That's what's going into my equation. And you know what? This time I'm going to use m. What is my function going to be then? Well, it's a function of m, function based off of months, and it's equal to $100 plus $40 per month. So you have that initiation fee that's based off of nothing and the $40 per month. What's your dependent variable then? The cost of the membership. Okay, hopefully you got that one right. If you didn't, go ahead and make corrections. Keep this in mind tomorrow, guys, and make sure you ask me in class what you missed on these notes. Functions often describe real-life situations, and you guys already brainstormed this. You thought about this in your pre-Chapter 4 journal on where functions are used, and we did our activity with measuring our forearm length and our height to see if that was a function. When this is the case, all values are not reasonable for inputs or outputs. Thus, we must restrict our domain to reasonable values. You guys are used to this. You do this all the time. We've talked about it several times this year. You restrict values that make sense. Time can't be negative. Distance can't be negative. Well, this is going to take it just one step farther. So let's look at this first situation. Joe has enough money to purchase 1, 2, or 3 DVDs at $15 each. So we need to write a function to describe each scenario and then find a reasonable domain. This is what he's limited to. He only has enough money for this. So my domain is going to be limited. What is my domain going to be limited to? What he can afford. And then my range is going to be limited as well. You might want to make a table if it helps. You may not need to. but it helps your work stay organized. I like tables, so I strongly recommend it. So I'm thinking, okay, he can purchase 1, 2, or 3 DVDs. If he purchases 1, it's going to cost him $15. 2 will cost him $30, and 3 will cost him $45. And put a dollar symbol over there. So what's my domain then? Domain can only be 1, 2, or 3. Those are the only amounts of DVDs that he can purchase. And what is the only amount of money that he can pay? Is he ever going to pay $20? No. Is he ever going to pay $50? No. He can either pay $15, $30, or $45. So here's a situation where they limited it for you. You just needed to make the domain and range match. Again, pause the video, try B, and then press play. A theater can be rented for exactly 2, 3, or 4 hours. The cost is $100 deposit plus $200 per hour. You don't have to write an equation here, but if you wanted to, oh, and I'm going to go back up here because I forgot, we do need to write an equation. It does say write a function. So this would be f of x is 15x. So again, if you want to make a table here, you can. What are the two things I'm talking about? You may have come up with the equation of, I'm going to use g of x this time. This first letter will typically be f, g, or h, but it doesn't matter. It's going to be based off of $100 for the deposit and then $200 for each hour. So what's going into my function? Hours. That should match what's in your parentheses. So x is hours, and hours can be either 2, 3, or 4. Over here then I'm talking about the cost. If I pay for 2 hours, I'm paying a total of $500. 3 hours, $700, and 4 hours, $900. Again, guys, the table is optional, but it does help your work stay organized. 2, 3, and 4 is your domain then, and your range will be the 500, 700, and 900. Typically, when we're listing the domain and range, we do leave the units off of there. So I'm not going to put the money over there, but I will put it over here in the table. Notice x is hours, so I have it defined right there. Last part then of today's lesson, guys, is evaluating a function. You're going to notice that this is number 6 on your notes. We're going to skip number 5. It's not even on your notes. I'm going to give it to you another day so we can do it together. So evaluate the function for the given input. If you want to find h of 600, I want to know what is the function when I put in 600. So instead of h of s, I have 600. That means everywhere that I see an s, I'm going to put in 600 here. You're going to keep that h of 600. Remember, guys, this is not h times 600. This is like your y. It's already by itself. Okay, this is what do I get out when I put in 600. So you're going to keep that. All you do then is rewrite the function. Instead of writing s, write whatever you're replacing it with. In this case, it's 600. And then you simplify. 1/3 times 600 is going to be 200. And then you add the 2. So my function, when I put in 600, is 202. Notice your answer is labeled. That is part of your answer, guys. Do not cut it off, please. Last one then. Over here, I'm going to find the function when I put in -12. Instead of s, there's a -12. So everywhere you see s, replace it. 1/3 of -12. Anytime you substitute, guys, you always use, hopefully you're saying parentheses. I've said that so many times. Does it matter in this case? No. But if s was squared, would it matter? Yes. So always use parentheses. I'm going to have my function then when I put in -12 to be -4 plus 2. So my function when I put in -12 is -2. All right, guys, don't forget to do your ET.